series of these episodes, alright, in an earlier episode of this series, I talked about the fact that group 7 elements are known as halogen because they are often producing salts when they react with other elements. Now, group 7 elements are very popular because of their high electronegativity, which means that they easily combine with metals or group 1 and group 2 elements to form salt. For example, iron can combine with chlorine to form iron 2 chloride or iron 3 chloride. Now, that leads me to chlorine. Chlorine is a very important halogen. Now, these group 7 elements, they are known as halogen, and they include fluorine, chlorine, iodine, bromine, and astatine. Now, let's have a chlorine. There's a way of preparing chlorine, and which is similar to the way of preparing some other halogens. Now, chlorine basically is prepared from when you combine manganese dioxide or manganese 4 oxide, and then you heat it with hydrochloric acid, and you pass it through water and pass it through concentrated tetraoxide 6 acid. You will get in a jar chlorine, which is the gas you get. So let me draw the symbol. So basically, when you have your Bunsen burner here, and then you in your beaker or rather flask, you heat a sample of containing manganese dioxide MnO2. Let's call it. Let's write it here. MnO2, manganese dioxide, and hydrochloric acid HCl. So whenever you have this setup and then you have a dropping tube, then you pass this gas through water. This gas is passed through water, a beaker containing water. So you close it, then it also passes out of here and passes into another beaker or tube. There's another sealed tube containing tetraoxide 6 acid. So whenever you do this, you get the gas of chlorine. So you get, at the end of the day, you get chlorine in a jar. So if this is a jar, so chlorine is the resultant gas. This is an example of how you can prepare chlorine. So basically, you have manganese dioxide or manganese 4 oxide here, and you mix it with hydrochloric acid. Then you under your flame or your heat, you heat it, and then there will be a gas produced, and that mixture of gases, when you pass it through water, the water will absorb any remnants of hydrochloric acid. And when you pass it through tetraoxide 6 acid here, that tetraoxide 6 acid will dry the gas, because in an earlier video I talked about the fact that tetraoxide 6 acid is a good dehydrating agent. It's also known as a hygroscopic substance, so it's a drying agent. So it will dry the gas, and when it dries the gas, at the end of the day you have chlorine gas left. So chlorine gas will be formed here, and it will stay there because chlorine is denser than air, so it won't flow out of the jar. So you will still have it there, and the air will be on top. So that is why this is possible. But in other gases, at times you have to collect them above water because they are less dense than air. An example of that is hydrogen. Hydrogen is always collected above water inside a test tube or a beaker, an inverted test tube or beaker, because it is less dense than air. But on chlorine, you just leave it here and it will stay. So that is an effect of the physical properties of these gases. Other example of elements in the group 7 series or halogen are fluorine, and fluorine, by the way, is the most electronegative element with an electronegativity value of 4.0, and other elements too. And if I were to rank the elements in order of their electronegativity, we have fluorine, we have oxygen next, we have nitrogen, we have chlorine. After fluorine comes oxygen, after oxygen comes chlorine, after chlorine comes nitrogen, after nitrogen has bromine, after bromine comes sulfur. So just in case you don't know, this is the elements in order of their decreasing electronegativity. So you can write it down as a tip. So the reason why I wrote it down is because you can apply this knowledge in when you are making balancing and when you are performing oxidation or reduction equations. So you can know that the most electronegativity element is the one that will often be the oxidizing agent. Then the least electronegative will be the one doing the reduction. So that was, by the way, So I talked about other elements such as fluorine, bromine, iodine, and a property of iodine is that iodine is often mixed with ethanol in a solution known as tincture of iodine. Because when you leave iodine alone and you apply it on wounds, it will be an irritating substance. So it's often mixed with ethanol to form tincture of iodine and is used in treating of wounds and as an antiseptic. So and then that's application of all these halogens. Thank you for watching.